Welcome to The Explainer. Sometimes the biggest breakthroughs come from just changing the words we use. Today, we're going to dive into this really fascinating paper that suggests the way we talk about breast cancer is actually getting in the way of treating it properly. The whole idea is that a simple language change could make a world of difference for patients. So the whole thing kicks off with this really powerful question. What if the very names we've been using for breast cancer are just plain wrong? Or maybe not wrong, but fundamentally confusing. What if we've been so focused on describing what the cancer looks like that we've totally missed the mark on where it actually comes from? Okay, so for decades, right, the most common breast cancers get slapped with a label, ductal or lobular. And you'd think that means one starts in a duct and the other in a lobule, but that's not it at all. Those names are just based on what the cells look like under a microscope. It's a look-alike game. And this isn't just a minor detail. It creates a huge disconnect that actually impacts how patients are treated. So to really get to the bottom of this, we've got to rewind a bit. We need a quick anatomy lesson, a little back to basics to pinpoint the real starting point for almost all of these cancers.
And here it is. This is the whole shebang. It all comes down to this one tiny structure, the terminal ductal lobular unit, or TDLU for short. It kind of looks like a little tree or a plant at the end of a branch, right? And get this, the paper points out that this little spot is basically ground zero, the scene of the crime, for something like 75% of all breast cancers. Wow.
And you know what's wild? This isn't some brand new discovery. Pathologists have been pointing this out for ages. There's this quote from 1979 by J.G. as a party that basically says, hey, if you want to find the source, you've got to study the early cancers. You have to look for the very first clues.
Okay, so let's do exactly that. Let's play detective and look at the visual evidence ourselves. When a cancer starts in this TDLU, what are the first breadcrumbs it leaves behind on a mammogram? What do we look for?
Well, the first hints are usually these super tiny specks of calcium. They're called microcalcifications. And they don't just show up randomly. They form two very distinct patterns. Think of them like visual signatures or biomarkers that actually tell us something important about how aggressive the cancer is.
All right, check out the first pattern. On the left, see how it looks kind of powdery, almost like little cotton balls. That's the visual cue for a grade 1 or a low-grade cancer. And then boom, look to the right. The pathology slide shows you exactly what's going on inside that TDLU at the cellular level. It's a perfect match. Now, let's look at the other pattern. See how different this is? On the left, it's more like crushed stones. It's sharper, more defined. And that's our signal for a more active grade 2 cancer. But here's the kicker. Look at the pathology on the right. It confirms again that the whole thing is happening inside one single swollen TDLU. The key point is it's not in a duct. So we've seen the sparks, right? The earliest warning signs. But what happens if those sparks are missed? Well, a spark can turn into a fire. The cancer doesn't just sit there politely. It starts to grow and break out. It becomes invasive. Man, this next image from the study is it's incredible. It tells the whole story. Look at the first frame, just a tiny, easily overlooked cluster of those calcifications. Now watch what happens over 4 screenings. See it grow? See it change? Until finally, in that last frame, it's become a full-blown invasive tumor with that distinctive star shape. And that shape, that's another one of those visual clues we were talking about, another key biomarker. When these TDLU-borne cancers go invasive, they pretty much always form one of 2 classic shapes. You either get that starburst, stellate shape we just saw, or you get something more round, circular or oval. Okay, so you might think we've got it figured out, right? We find the tumor, we know its shape. But it's not always that simple. The story gets a bit more complicated here because we've only been talking about a single tumor, and that's often not the whole picture. Yeah, this is a really big deal. The paper highlights that about a third, 1 out of every 3 breast cancers, are what's called multifocal. And that just means it's not one single tumor. It's multiple separate spots of cancer. It's like seeing one tree, but completely missing the fact that you're in a whole forest. And that creates a massive problem for the way we currently measure and stage cancer. The standard system, called TNM, has a major blind spot. It only looks at the largest tumor. So you can have 5 tumors, but it only measures the big one and basically ignores the others. You can see how that would give you a totally wrong idea of how much cancer is actually there, right? Just look at this case right here. The mammogram on the left and the MRI in the middle, you can clearly see there's more than one spot. But then look at that big pathology slide on the right. That gives you the God's eye view, the full, undeniable extent of the disease. It's a reality that you would completely miss if you were only allowed to measure the one biggest tumor. It's just not the full story.
So what does all this add up to? We have confusing names, and we have a measurement system that can miss the big picture. And that has very real consequences for patients. So after laying all this out, the researchers propose a solution. And honestly, it's a beautifully simple one that's based on all the visual evidence we've just walked through. Here it is. They suggest a new, unifying name for all of these cancers, acinar adenocarcinoma of the breast. Let's call it AAB. And the name actually means something. Acinar points directly to the acini, those little grape-like sacs inside the TDLU where it all starts. Finally, a name that tells you where it's from, not just what it looks like. And this table just makes it crystal clear, doesn't it? On one side, you have the old system. Confusing, look-alike terms like ductal and lobular. On the other side, you have the proposed system. One single, clear, precise term, AAB, that's tied directly to the anatomy, to the TDLU. It's a shift from confusion to clarity.
And look, this isn't just about making things tidier for the doctors. This is about real-world impact. Why does this matter? Well, first, doctors can actually talk to each other without getting confused. It means we can get way better at predicting how a patient's disease will progress. That leads to smarter, more personalized treatment plans. And, this is huge, it helps us avoid over-treating some of these small early-stage cancers that might get mislabeled as something scarier than they actually are. You know, when you think about it, our imaging tools, our mammograms, our MRIs, they give us this incredibly clear picture of what's happening inside the body. We can literally see where these cancers begin and how they grow. So the paper leaves us with this one final, really powerful thought. If our tools can see the truth so clearly, shouldn't the words we use reflect that same clarity?